Hey everyone, in this video I'll walk you through setting up and testing a stretch Kafka cluster using Strimzi and Submariner. I'll explain the key configurations required, I'll set up secrets, deploy Submariner, and then test if everything is working properly. So I've got three OpenShift clusters, cluster 1, cluster 2 and cluster 3. And I have installed Strimzi version 0.44 in all of them. I'm using my custom image for this demo purpose, so I am going to show you the image. So this is the image which I have built for this prototyping. Now let's first look at some of the key environment variables that enable the stretch mode in Strimzi. So the first one is Strimzi stretch mode. This tells Strimzi that we are running a stretch Kafka cluster across multiple Kubernetes clusters. Normally Kafka runs within a single cluster, but with stretch mode we can distribute brokers across different clusters. Now the second one is the Strimzi K8s clusters. This defines the Kubernetes cluster involved in the stretch deployment. Here we have cluster A.url, cluster B.url and their corresponding kube secrets. So these are nothing but the API endpoint of our Kubernetes cluster. Each cluster has a corresponding kube secret which contains authentication credentials so that Strimzi can manage resources across these clusters. Now the third environment variable is the Strimzi network policy generation. This is an environment variable which Strimzi provides out of the box. This disables automatic network policy generation when we set it to false, and since we are using Submariner for inter-cluster communication, we don't need Strimzi to generate network policies automatically. Now we need to create Kubernetes secrets to store the kube config for each cluster. This allows Strimzi to authenticate and manage Kafka brokers across multiple clusters. So let's go ahead and create these secrets. And for that I'll go to the documentation which I've prepared. Click on deploying Strimzi in stretch mode and scroll down to find this particular stuff. So I've got this kube config in files named cluster a.config, cluster b/config. So I'll just copy paste what I've got here. This will create secret in the central cluster. I'll show what the secret looks like in a moment. So if I go to the central cluster, click on secrets and click on reveal values, you can see that these are just basic kube config files in a secret. Now that's then the second step is to deploy Submariner. To save some time, I've already deployed Submariner. So these are the commands which I've used to deploy Submariner. Everything is documented here in this particular link, installing Submariner on OCP. So I've used subctl deploy broker globalnet to deploy a broker in the central cluster. You can deploy broker anywhere in the any of the three Kubernetes clusters, it doesn't matter, but I've deployed it in the central cluster. And the -- global net flag is required to support overlapping CIDRs in the connected cluster. So Submariner has a component called global private network or global net. This is a virtual network specifically to support Submariner's multi-cluster solutions with the global net CIDR. After that, I have joined all the three Kubernetes or OCP cluster to the Submariner cluster mesh. Let's do one thing. Let's verify if the Submariner installation is fine. So for that, I'll go to the documentation again and I'll run subctl show connections. This command will help us verifying that the secure tunnel between our cluster is established so that the Kafka broker can talk to each other seamlessly. So this look like this connection is fine. Now what I'll do is I will check for other clusters as well. Kubeconfig cluster a config. this will check the connections for the second cluster, and this will check the connection for the third one. Now if I go to this documentation, let's check one more thing. um, let's diagnose the firewall settings in use. If I copy this one and hit enter, I will be able to diagnose firewall intra cluster. I'll do the same for the remaining two cube configs and see if everything looks okay. It looks like things are working fine. Alright, cool. And the next step is to apply the YAMLs, the Kafka and Kafka node pool CRs. So if I go to this documentation again, I can copy the whole thing and paste it in the central cluster. This should create ports in remote cluster. So if I go in here, I can see that ports Strimzi cluster operator is running in this 3 Kubernetes cluster. We'll have to wait for some time for Strimzi to create all the required resources in the remote cluster, like service accounts, cluster CA, or and certificates and config maps and all those things. So it will take a while for Strimzi to generate all these things in remote and the central cluster, and once that's done, we will be able to see the ports coming up in these clusters. In the meantime, we can go to the remote cluster and search for service accounts with name my cluster. You can see that this new service account has been created. Then we can look for, you can see that port started coming up. So it has created all the required resources in the remote cluster. Meanwhile, I'll show you what all resources will be created in the remote cluster. So service account is one of them, Strimzi ports, that is the second one. Then it will create a bunch of config map required for the controller and broker port. It will create secret resources. It will create service required for communication. Then it should create service export as well. So this is required for Submariner to expose service across Kubernetes cluster. So all these resources will be created in the remote cluster by the operator running in the central cluster. Now that the ports are up and running, we can do some testing to verify that things are looking fine. So what I'll do is I'll take my Visual Studio Code and I will exec into one of the broker port which is running in remote cluster 1. Once I've logged into the cluster, I'll run a console producer. I'll open up a new terminal. We'll run a console consumer in Kubernetes cluster running in a different. Alright, now I need to run this consumer. We'll send some message. Yeah, it looks fine. Now we'll stop the console producer and the console consumer. We'll run some other commands. Now I will run the describe topic command and see where the partitions are and the ISR for that partitions. You can see that the replicas are in 7, 8 and 12, and the in sync replicas are 7, 8, 12. So everything is in sync and the leader is 7. Now let's run this command and check the replication distribution. Or yeah, you can see that for the entire cluster, 9 is the leader, and these are all followers, and these are the observers. Let's do the metadata quorum listing as well. So if I copy this one here, well, let me clear the screen and paste it in here and see the metadata quorum listing. You can see that the leader is 9, the current voters are 16, 17, 8, 3, and so on. So these are the controller ports, and the observers, these are the broker ports. So it looks like ports running in different Kubernetes clusters are connected together, and it works as a single logical cluster. So yeah, that's it. So we have set up and tested a stretch Kafka cluster using Strimzi and Submariner. We have enabled stretch mode in Strimzi. We created secret for Kubernetes authentication. Set up Submariner for intra-cluster networking. We did some bunch of testing like produced and consumed messages across multiple cluster. We listed the metadata quorum. We checked the replication and things like that. So this setup allows Kafka to be highly available across different Kubernetes cluster, ensuring fault tolerance and scalability. So yeah, that's it. So if you found this helpful, feel free to leave a comment or reach out. Thanks for watching.